Okay, welcome to week 9, application exercise 6. In order to get started, you'll need to go to your doc sharing and download application exercise 6 instructions, as well as the application exercise .xls file. That's application exercise 6.xlsx. Alright, so that'll bring up this document right here as far as the Excel file. And you'll have a Word document as well that has the various questions in it. So to start with, under the tab Sum Product, calculate each applicant's total score using the Sum Product function. Alright, we are in the Sum Product tab, and essentially what we're trying to find out is this times this total. So the weight of the qualifications for these applicants is higher than reference, interview, and appearance. And so we want a calculated value and a sum for each one of them. So instead of creating separate columns where we calculate these and then we add these up, we can actually go into the total score and we're going to create a function. I clicked on the actual function FX key, and it's going to open up a dialog like this. And you can actually search for the function that you're looking for. So if you're looking for a sum product, you can start typing in sum product and hit enter. It asks for 2 arrays. So we need 2 columns of data. We're taking the first column and we're multiplying it in array 2 times that second column, and we get the value of 8. Now, if we try to drag this across there, it's not going to work. So we've got to, again, FX, sum product, select the weight, then select applicant B's values, and we get 8.2. So we're going to do that all the way across here. And again, alright, so we've got a sum product value for each one of the applicants. Next, it asks us to highlight the applicant that would be hired based on the weighted scores, which is the highest score. So by looking at this, we can quickly see that applicant B was certainly the highest value here with 8.2. Next, we need to create a chart comparing each applicant's total score and move to a new tab titled Column Chart. Okay, now we're going to go to the GoalSeek calculate the following under the tab GoalSeek. Calculate the following scenario. Avon took out a loan for $500,000. The original financing came back at 4% with monthly payments of 5 years. Calculate the payment. Alright, so we're going to plug in some of these values. We know that the loan amount was for $500,000. The number of periods, which will be the 5 years, and it's a monthly payment. So that's going to be 5 years times 12. So we have a total of 60 payments. The interest rate is going to be 4%, but it's accrued monthly. So that's going to be divided by 12. Oh, and we're going to have to put in the equal sign so it actually calculates that. Alright, we want to figure out the payment. The original value is 0. And we're going to figure out the payment. To figure out the payment, we're going to use the formula builder. If you don't see it, click the FX and you will see it. PMT will bring up payment. That's PMT. And it's going to ask us the rate. It's going to ask us the number of periods. it, oops, let me clear that out. Start this over again. Alright, it's going to ask me the rate. Then I'll have to click over here for a number of periods, 60. And the loan amount is actually going to be negative because you're borrowing, so negative 500,000. The future value is going to be 0. We want to pay it fully out, and the type is 0. Don't worry about that, and hit return. So now we have our payment amount, which is $9,208. The next part of the scenario is that Avon really was wanting to keep the payments at $9,000 using the goal-seek function. How much can they afford to take out in loans to get their payment to this amount? Alright, so now we're going to take, let me escape out of that, and I'm going to copy these values down to goal-seek, and we want to get this value, the payment, down to exactly $9,000 and find out how much they could borrow and have that payment. So what we're going to do is a what if statement, and we're going to click on data in the tabs and what if goal-seek. Now it's going to ask us to set the cell. We're setting the payment. We want it to be $9,000, and we want to change the loan amount. Hit OK, and now we know we could borrow $488,691 and some change, and keep our payments at $9,000. Alright, the next part of the scenario is TAMUC Commerce MIS department needs to purchase a new fleet of computers. The department takes out a loan of $200,000 to cover the cost at 5% with quarterly payments for 5 years. Calculate this payment. Excuse me. TAMU Commerce really needed their payments to be under $11,000. The price of the computer is fixed and cannot be adjusted any lower. Using the goal-seek function, how many periods can they extend the loan to get the payment to $11,000? So you're going to use the same equations essentially as we just did. The exception, and I'm going to let you do these two on your own, having the experience of the previous one. But I will point out that keep in mind the payments are quarterly, not monthly. So that's going to change two values. That's going to change your number. Oops. Your number will not be 5 times 12 because you're not making monthly payments, and your interest, which this really should be rate, will be 5% according to this scenario, but it won't be divided by 12, it'll be divided by quarterly. So keep that in mind as you do it, and then we'll move on to question number 3. Under the tab Data Table, calculate the following scenario. Loan amount $250,000, monthly payments for 4 years, interest 3%. Alright, and then the following will be calculate the payment and then create a data table for months 12, 24, 60, and interest 2.5, 3, and 6%. The reason I mentioned that second one is because we're going to lay out this one slightly different than the others so that we can more easily change the period of the loan and interest rate. Alright, so I've already started by putting in the original amount, the loan amount, years, period, interest rate, and rate. So this time I separated out the period in years rather than multiplying 4 times 4, or I'm sorry, 4 times 12, or in this case, yeah, 4 times 12 for monthly. I also separated out interest rate and the actual rate so that we can change the interest rate and it will change our effective rate here. Alright, so I am going to create the payment formula and select our rate. Our number of periods is actually going to be these two values multiplied. Oops. If I can get it to multiply. There we go. Alright, the present value, again, it's going to be a negative, so negative 250,000. The future value is going to be 0, the type is going to be 0, and hit enter. So we've got our loan payments for 4 years. We would be paying $5,533.58. Alright, so we want you to create multiple values, and you're going to be able to check by increasing to a 5-year. And you can create 5-year effectively is 60 months. So you can see the effects of it and answer the remaining questions here as far as a 12-month, 24, 60-month interest rate. So 12-month would be 1 year, 24-month would be 2 year, and we just did the 5-year. Then also make one for 2.5, 3, and 6%. So you are going to essentially have, we've done 3% at 4 years, or 48 months. Then you will have multiple variations, and we'll just carry this across. Oops. So we are able to quickly go into the 4-year, and we can create a 2.5% interest. We can create a 6%. We'll go ahead and just for the fun of it, we'll put in a 5% and a 6% interest. Then you could copy that whole block and adjust your years or months. So if you wanted to do a 1-year one all the way across, you could do 1 year all the way across and see what the payments would be for 1 year, as well as the payments for a 2-year and 5-year. So you'll have quite a few in your tables, but it'll allow you to look at what loans would be best suited for you. If you were to finance a car or a home, you'd be able to kind of figure out what your payment would look like, and if you really want to get into it, you can create a payment schedule or amortization table. But for this assignment, I'd like you to complete these and submit that assignment. Thank you very much.